Yeah.
Number 9 on 2-2.
Okay. Lord's eraser is from 1960. Still works. What the hell? Let's see. 9. This is separation of variables. Where'd it go? There it is. So you got to realize, any method from 280 that you learn, integration method, well, that's the first thing you did was learn all those fantastic integration methods. We haven't seen it yet, I don't think, but there could be some trig sub in your future. It could happen. Sorry.
Like not do that. Can we not do it? I guess give me that.
Yeah, you could always skip it and just,
Give me that.
I can, yeah, that's easy for me to do. I don't know why you want me to do that.
That's work for you.
So how do I separate this?
Multiply the.
I mean, it kind of naturally wants the x stuff on this side, right? So I can kind of multiply and divide. Now, what can I do with this? The x squared I can
Exponent.
take up there, right? And I got y plus 1 squared, and then I got that y that's got to come divide, and I got that dy that wants to multiply up. All right, so that's separated. Keep them separated. And now you just attack with integrals, and like somebody muttered. Now here, this is easy, right? You just FOIL it out. You can divide each one by y. When the bottom is a monomial, it's like, oh, thank God. Right? So some u-sub operations just make the bottom u and then hope it works out, because then the bottom is a single term, kick ass. When the bottom's not a single term, it sucks. Over here, yeah, you're going to have to use by parts, yeah. By parts shouldn't be that. Come on. I mean, that's, yeah, I'm not going to do it for you. I mean, this is the separation part, and now you just have to remember how to do this. Remember how to do this. Right? And in Math 180, it's sort of like when the teacher said the rest is algebra, and everybody was like, can you finish it, please? So now I'm saying the rest is 180, and I'm not going to finish it. It's you guys. Was there a question on where to go from here, though? Was that part of it?
I figured it out right now, though. I did the integration by parts, but I made the wrong term.
Oh, okay. I got you.
Because after you finish doing the whole integration, right, you have to stuff plus c equals to stuff. How do you simplify down to make solve for a variable?
Sometimes, all right, so just like on the quiz, if you have like your x is squared and your y is squared, you basically leave it as implicit. You don't want to solve for either one, because then it has to be a plus or minus, and that's not generally a good way to write it. You leave it as implicit. And then you can attack it later if you need to do something based on where it is you live, right? Based on which one is going to be the thing you use. I don't know if that made sense, but is that what you're asking about? Like how to solve for what, right? Separable is kind of like you could solve for either one, to be honest. Whichever one is easier to solve for, because on a very basic level, it doesn't matter who's a function of what, truly, almost ever, unless it's like a second order where it's d squared y, dx squared, and then y is kind of a function of x in that case. It's sort of set up that way as an expectation, yes?
Weird question. I noticed in some of the examples that they were moving c to one side. Is that preferential, or is that needed to be done, or can you just have
well, if you could solve for y, then you're going to have y equals, and whatever c terms are with it, you're going to move over.
Okay.
Just to get y by itself. I don't know if that's why they were doing it. If I'm leaving it as implicit, where the x is squared and the y is squared, whatever, it doesn't matter with anything where that c ends up, really. Is that cool? Yes.
Does it matter which one you treat as the independent and which one
But
is the dependent?
and do you see how you could argue like here, but I split them up. So it really doesn't matter. It's just a matter of, is it easier to solve for one or the other? Now it kind of matters in the problem if they say, well then what if x of 2 equals, oh, and then they have x as a function of y. You kind of see what I'm saying? So it's kind of, if there's something else and you're like, oh, that's the direction they want me to go in. If there's none of that, just to solve it, who gives a shit, right? We're at the point where we realize the x-axis and y-axis are where they are completely arbitrarily, so who cares? Right? Okay. And they're x and y, completely arbitrary. Well, x is an interesting history, but I'm not going to go into it. Okay. Anything else from, is that good enough for that? Is that, yeah, okay. Anything else from homework stuff? You guys doing all right? Everybody's all right? Yes.
Can you explain like number 12? Because like I just kept on doing,
12 and 2-2?
Yeah, I kept on doing like tricks of but I just kept on.
Oh, trig sub means you have like
Identity.
1 minus x squared, some identity where you substitute the variable with a trigonometric expression, right? That's trig sub. I know what you're talking about. You're talking about like a u sub with trig in it, or something related to that. Which one was it again? Number 12. Okay. So you got sine 3x equals, oh, sorry, plus 2y cosine cubed 3x dy equals 0. Dude, I gotta get some reading glasses. That sucks. Let's see, blah, blah, blah. Getting old is exciting. Okay. So this is almost separated for you. So you just subtract that stuff over. I'm going to divide by this, which really gets your heart going. So you get sine 3x over cosine cubed 3x dx equals negative 2y dy. That side's nice. It's a lovely coefficient to have. Okay. So this side obviously is the first one. So, I mean, you start looking for example, and again, you should remember this, and this is more general, but definitely with trig identities. You can try something and that was the wrong way to go. Who cares? Trying it and seeing it was the wrong way is a part of the process. It doesn't mean you're an idiot. It doesn't mean the whole thing is shit. It just means that's a part of the process. So one of the first things I look for when I got sines and cosines, of course, is like, well, also this is, all right, but, okay, you could do that. I look for cosine squares so I can get more sines in there, right? Say again?
You could factor out a cosine from the denominator and then have a cosine squared.
Now, to be completely honest, I wouldn't even do any of that. I just want to see if you guys would give me some ideas. Yes?
I did it with you.
There you go. Is there a function who's captured somewhere whose derivative is free to move around? I mean, that's how I try to teach u sub. This is caught on the bottom, right? So, but what's its derivative? Not cosine cubed, cosine. Cosine's derivative is negative sine. Sine with a constant, who gives a shit about constants? Which is that, right? And of course it's going to have a 3 in there, but again, who gives a shit about constants? You make those work. What matters is when you're checking to see if u sub will work, is somebody's function that's caught somewhere is its derivative somewhere that's free. Then u sub is going to kind of work, right? Yeah, so you don't even have to worry about, so if you let u equal cosine 3x, what's du? Negative 3 sine 3x, so I need a negative 3 up there. All right, keep going. Then you're going to have 1 over u cubed, right? Is that all right? I like how I just did. Here, this is part of my explanation. Oh, Jeff. Oh, I see. Yeah. So to be honest, I kind of wanted to see what you guys would say as far as giving me ideas for identities. But I was kind of also hoping somebody would go, "What the shit are you guys doing?" Because the very first thing you do, you rule out the easiest thing, and what's normally the easiest thing? U sub. So you rule that out, which means you try that first.
I don't apparently.
Huh?
I don't apparently. I go to the hard stuff.
Oh shit, yes. Because I kind of understand that defeatist attitude that, you know, the problem It's assigned. It's probably hard as shit. You just try the hardest thing and get this over with quick. No, come on, no. I'd be a little more optimistic.
No.
Okay, well, don't. Is everybody cool with that problem? Everybody cool with how to proceed on that problem? Okay, it's not a major trig identity yet. Anything else from homework stuff? Okay, let's get back into where we were. Let me see if you guys remember how to check. Let me put the general idea up here first from where we're in 2.4. I have a handout I'm going to give out right before you guys leave that's got like a summary of all the chapter 2 methods. It's kind of a nice handout.
Thanks.
So look at this. Tell me, is this, can you, oh, that's right, I was going to write it generally first. So if I have m dx plus n dy equals 0. M and n are both functions of x and y. This is that very last thing we did last time. Where I started with an f, I started with the answer and showed you where the dE would come from and gave us an idea of how to actually solve it the other way around.
You said that M and N are
Yeah.
functions of both x and y?
Yes.
Okay.
Which means they could have both or neither or one of them. All right. How do I check to see if this is exact? Chef. There you go, buddy.
You see if there's a partials or
Yeah, and that was related to Clairaut's theorem. If you don't know Clairaut,
yeah, if they're
Clairaut,
equal.
exactly. I always think about Silence of the Lambs when I say it. It's so funny you said that. Clairaut. So you've got to check to see the partial of n with respect to y, because it's already been done with respect to x. I want to see if the cross derivatives, the cross second derivatives actually match. So if the partial of n with respect to y is the same thing as partial of n with respect to x, that must mean they both came from the same generating function. Okay.
There was a term for that, wasn't it?
Term for which part?
When that exists, that can help them.
No, it was Clairaut's theorem. It was this m is fx, and this is fxy equals fyx. Yeah. Yes.
Can that 0 be any constant? Or does it have to be 0?
Oh, so here, yeah, this has got to be 0.
Okay.
For right now, there are adjustments we can make, but it's 0. Yeah. And really, it's because we're assuming that it comes from some function equal to a constant. So that side is going to be 0. But that doesn't mean if it's not 0, you can't do anything. We'll get there.
Is that f of xy equals c or 0?
C, sorry. I tried it. So when you find f, how do you write your answer? You write it equals a constant. That is the answer to one of these exact equations. Why? Because that's where it would have started. That's where we started last time, as an example. Okay, let's try like just a problem that we have to check. You guys check to see if this is exact. And this might be related to a very simple mistake people make. I'll show you now so you don't make that mistake again. So who thinks they have the answer? Is this exact? That's all I want you to do right now, right? I said just check to see if it's exact. Don't solve it. Is this exact? Who thinks they have the answer? A few people say no. Somebody said yes. Is it exact? So the mistake that people make is this is not in that form really, or at least realize m is this, n is negative this. Right? Shit. So dm dy, partial m partial y is 1, but partial n partial x is negative 1. Nope. So it's also a mistake when they have like, if I put this equals this, it's not in that form. You're supposed to pull that stuff over. Do you see what I'm saying? So the thing with a lot of our methods in DE is the form has to be met because that's a requirement for the process to kind of work. This is built off of that form. It's kind of hardwired that way. All right, how we doing so far? Is that decent? So the check is relatively simple, I'm hoping. What about this guy here? Is this exact? And then would you actually solve this the exact way? It's kind of a good tell here. This is a situation where students get so absorbed in it they don't step back and see something really evident. So here's m, right? What's the partial of m with respect to y? 0. What's the partial of n with respect to x? 0. Is it exact? Yes, because those are equal. Would I solve it the exact method? Oh, hell no. If I ever see that, it is separable. In fact, it's basically already separated. I just have to move that. Do you guys see that? So that's when we got to take a step back. Don't get so absorbed in something. Sure, that's exact. Sure it is, but they both came out to be 0, which means there's no y dependence here and no x dependence there. It's already separated for the most part. Just move them to opposite sides and attack. You guys with me? Because the exact procedure is relatively easy, to be honest, unless you're new to it, but then you're just new to it. It's not hard, you're just new. But it's longer than it has to be, especially for this guy. Shit. Okay. Let me say that better. There's some things you have to solve that way. But for this one, it would be longer than it would ever have to be to do it that way. That'd be crazy.
So is separable like always easier? Or like
Only if the parts of it are something that's really hard to integrate would it be harder.
okay.
And there are cases where a different method would kind of allow for a different organization of the problem, which would make it easier, but I mean that's really not common. If it's separable, that's almost always the way to go. Okay, maybe. Okay. So let's do one all the way up. Let's check it and solve it. Because obviously this is just 3% of the problem is just checking it. Let's get one that's a little more interesting. Ooh, this one's gross. I like it. All right, we'll do this one together. Shit, I'm always out of time. When I start? God damn it. See what I see that. What's 6 extra? Get the large font edition. All right, how do I start to check this if it's separable? Not separable, exact. How do I start to check that? Get it in the correct form. So part of that is just, and then sucking it over, right? So it'll be x dy. That would multiply that up, bring this over. So all these are going to change signs. Is that cool? Let's just cut to the chase. So it'll be plus y minus 6x squared minus 2x e to the x dx. Become a square. There you go.
Since it's difficult math, that's m, that's dy dictates to x.
So I multiplied this up, and then I subtracted everything over, so all the signs changed. Is that cool? Yeah. So now it's in the right form. Is it exact? Yeah, and be careful. See, it's out of order.
Yeah, so nothing.
So this is actually n. Who cares what m and n is? This has already had y done to it, so what do I have to do to it now? The other one, x. Do you guys see how to look at this? So if they're out of order, you're not going to make a mistake. So this is going to be, what's partial of x with respect to x?
One,
And this is going to be partial of all this shit, which really the only thing that matters is
one.
that guy. So that's 1. So check, they are equal. Those cross derivative terms. All right, so now let's do this process. I did one a little bit quick last time. Let's go a little slower through it this time.
But wait, if there's always one, they don't equal 0.
They have to equal.
All that has to be true is that the derivative partials have to be equal to each other.
I thought they'd be 0.
No. The last one we did, they just both have to be equal to 0.
Because when you subtract them in Clarice's theorem, then y equals to 0. In order for them to be 0, it has to be
They have to be equal.
equal.
Yes.
That's what it means.
Yes.
It's
So
zero.
Claro's theorem says that the partial of f with respect to x and y has to equal the partial of f with respect to y and x. Yeah, like that. That's not what we're checking. We're just checking to see if the second derivative, partial derivative, are equal. Those second derivatives are equal. Everybody cool with that? You've got to check to see if the partial of m with respect to y is equal to the partial of x with respect to, partial of n with respect to x.
So,
You're checking that.
do you know exactly why that means it's an exact?
Well, all right. So this idea,
Yeah.
all right.
Like, I
The reason
understand
it means
the
it's
test.
exact is the whole lecture I gave last time. Because I started with f of x, y equals c, and I took derivatives and showed what kind of DE it would end up with.
Oh, yeah. So if you work backwards.
So now
that
I'm
was
just
a
saying, see, that's the way I like to show it. That's the motivation for why the procedure works.
Gotcha.
I like it. Okay, that was the method behind the madness for that lecture. Yes.
What page in the book are these examples?
2-4 is exact equations.
Okay.
Yeah. I just pulled this out of the homework. I just saw one I liked. This might be one of your homework ones. I don't know. Didn't check that. All right. Somebody's like, no. Okay. So this is the check, and again, just like I had up here earlier, you check to make sure the dm dy equals dn dx. Okay. So how do I do this? What must this be, for example? This must be partial of f with respect to x. Because we just checked to make sure that f exists. If f exists, this must be the x derivative piece. Are you guys all cool with that? Okay. So that means in order to figure out what f is, all I have to do is integrate this. Ooh.
There's like 5 parts in it.
Yeah. You see why I put that in there now? So we can maybe review that as a part of this problem. All right. So f is going to be the integral of this with respect to x. Kind of partially, right? We're just treating y as a constant. So these first couple pieces are easy, right? Yeah, so I get xy minus, this is beautiful.
2x.
Yeah, 2x cubed. I had a 3-piece I could suck up there. And now this integral is going to take a little bit more work. Oh, no, yeah, he's doing it. Okay. That's a beautiful biparts, to be honest. I mean, that's the biparts you wish for, right?
It's e to the complex.
Yeah, u is definitely going to be x. X could be either, but I got a polynomial piece that'll disappear, so of course I'm going to u. I'll have to do one level of this, right? So du is dx. What's dv? dvx dx. So v is dx. Is crazy. So let's see, I get f equals xy minus 2x cubed minus 2 times, how's it go? uv
Integral of v.
minus the integral v du, which is just
It's e to the x.
dvx. Some of you guys might even remember this, or I don't know, maybe.
That's a cheat sheet where you just like put all the derivatives.
Oh, yeah.
inside and just
I'm with you.
plus
Whatever
it.
methods you've picked up on the way, it's
Remember
great.
that guy's name is? What?
Yeah.
There's a method where this e to x bracket times a polynomial, just do the derivative one side and do the integral one side, then you just cross it and there's a plus or minus system.
Oh, yeah, yeah. Okay.
That one time, doing that with them.
Students normally hate the fact that I wish we had less songs and sayings and bullshit. I mean, it makes it interesting, you can laugh about it in class, but then you get further removed from the idea. And the more away from the idea you get, the less you can build on. And that's not a very popular or interesting thing to say, and I don't care. It's just the truth. There's like FOIL method and SOHCAHTOA, those are funny things, but they're completely unnecessary and they screw people up later. Anyway, another rant from Jeff, sorry.
Then plus the.
Yeah, plus,
The C
good.
or the,
So now there's going to be plus a constant, but what's the constant in relation to what we just did?
it's a function of y.
Function of y. We just did with the partial of x, so that must mean y is a constant, so therefore, instead of putting plus c, that's the weirdest part of this whole thing, but hopefully you guys get, I'm undoing a partial derivative. Therefore, the constant would be any function of y. Now, do you guys see why I could have started with this, but I don't know if you guys... all right, so you'll see in a minute. So I normally start with the uglier one, to be honest. Now, what is this? Got to be, just because of where it is. This has got to be partial of f with respect to y. So I know that has got to be the partial of f with respect to y. It's got to be. But I know what f looks like. Down to an unknown function of y, but I know what it looks like, right? So I just have to take the partial with respect to y and compare it to what it's supposed to be. That's always the process, always. When do you do that? Always. When? When you got an exact, you do this. Which step? All of them. So what's fy? What's partial of f with respect to y? Which, just to get you guys used to it, if you're not used to it, that's another way to write it, is just fy. Fy. And what do you get when you do that? Everything's dependent on x except two things. Yeah, so it's x, dead, 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 plus g prime of y. Are you guys with that? Fy, so x is a constant, so this is just like 2y, that would be 2, so xy is x. Everything, all the other x pieces die, and that's the function of y. So what must g prime of y be then? G prime of y must be 0, because there is nothing there. So what is g of y?
See,
Just a constant. That's going to be the constant at the end. Okay. So there is a process in here. Check. Pick one of these things. Normally I would pick the grosser one, but it doesn't really matter. Integrate it with respect to, the thing that it was differentiated with. Is everybody with me so far? Figure out what the form of f is supposed to be. Take the derivative and compare it to what you know it is. And then you make this become whatever is missing. Whatever is missing. That's how that works. Why do I know it's going to work? Because I checked. All this shit will work if the check works. There's no way to have something not match. That just means you integrated wrong. Something went wrong. All right, so what's the answer here? Shit. That sometimes is the hardest thing to get. What's f? It's xy minus 2x cubed. Where'd it go? Minus 2x e to the x minus e to the x. You can distribute that. Plus c. So I'm just going to move that over here. You make this c1 just so nobody yells at me about it being negative or some shit like that. The answer is always going to be f equals c, because that's where it would have started from if it's exact. Yeah.
Why did you put C1? Oh, because you changed
Because
it?
technically it would have been moved over and it would have been negative. See what I'm saying? If g is c, I would have put a c here, and then I would have subtracted it over.
Yeah.
You with me? Okay. That part's not that big of a
the
deal.
Same C.
In fact, the g you normally don't even worry about unless it's something other than a constant, because it's just going to get sucked in over the other side. To be honest, I wouldn't even have written this, to be honest with you. Well, that's nothing, so screw it. It's over there with a constant. Okay, maybe. Maybe not. Okay. We got like no time as always. It's crazy. Let me give you this here. You're all like, just stop giving us quiz. We have so much time. You guys remember what Monday is, right? Holiday. Some of you guys got confused. No, it's a holiday. It's the opposite of that. Whatever you're thinking.
It's all short because I forgot.
So don't.
I did that
No,
week before. I
don't
missed one
come.
thing. Should have 22nd. Text me. I was like, ooh, it's dead.
Don't come Monday.
Come Monday.
Wednesday, I'm going to have a practice test for you guys. And the following Monday is going to be review day. All right? I totally lost count. See that. You guys with me? So that following Monday, I'll have the answer key for that practice test. We have one section left, the 2.5 section. So I kind of desperately want you guys to try to read ahead a little bit. It's on the bottom. Try to organize this all nice.
Bernoulli, wasn't he a chemist?
Bernoulli was, oh my God, dude. Good
Yeah,
Lord.
We used one of his things in Physics 3.
Bro,
I don't remember. It was a derivative or something. I don't
he's
remember.
almost as bad as Gauss in terms of like, leave some shit for other people. Right? I mean, Gauss is like, he did what? Did that? Was that? Bernoulli's the same kind of thing. Yeah.
Just all over the place. Contributed to a little bit to everything.
Is that the same?
He's in probability, he's in air, airflows and stuff, and pressure stuff, and, it's insane. And yes, so he's obviously in differential equations because that's got to do with flows of things. So, hey. All right, that's it for tonight. I'm not going to try to cram in anymore.